to solve the second order linear ordinary differential equation, we have learned about method of undetermined coefficients. So however, so there are four cases, which are the first case is when your fx is a polynomial, and second case is when your fx is in term of exponential. Third case, when your fx is either cos or sine, and the fourth case is when you have addition of either the addition of case 1, case 2, or case 3. However, when the coefficient of when your fx is other than that three cases, such as tangent x, secant x, or 1 over x squared, or ln x, it will be quite complicated to use the method of undetermined coefficient. So in that case, we can use method of variation of parameters. Okay, so to get, if you have a non-homogeneous equation, we remember in this term. So in this case, to use the method of variation parameters, this method can handle all types of fx, okay, including tangent x, secant, and so on. Alright, so as usual, the solution for this differential equation is yx equal to yh plus y p. So method of variation of parameters is used to find the value of yp. Yh, we still use the same method as in undetermined coefficient method, right? So how to get yp using method of variation of parameters? So first, we must identify a and fx, where a is the coefficient of d square y dx square. So we must determine the coefficient of d square y over dx square, and fx as usual. Alright, and then determine a homogeneous solution. So in this case, the homogeneous solution plays an important role, because you have to choose y1 and y2 from the homogeneous solution. If your homogeneous solution is wrong, then you will get wrong solution for your particular solution. You will get wrong answer for your yp, because this y1 and y2 will be used to find Wronskian w. Okay, so what is Wronskian? So you have to multiply y1 with y2 prime, okay, and then minus y1 prime times y2. And then next step, you have to find u and v. So this is the definition of u and v, right? And the general solution is yp equal to uy1 plus vy2. So your y is equal to yh plus yp. So let's try to solve an example and take a look back at the steps. So the differential equation is y double prime plus y equal to secant x. So the first step is identify a and fx. So a is the coefficient of y double prime. So your a is equal to 1. And from here, we know that your fx is equal to secant x. Alright, so we have to find the homogeneous solution. Okay, step 2, determine homogeneous solution. So find yh. So again, be very careful to write your characteristic equation. You see here you have y, not y prime. So you will have m squared plus 1, not m squared plus m. Again, I repeat, if you have only y, it means that you have just constant. You don't have any m. Unless if you have y prime, then you will have m. Okay, so m squared plus 1, okay, equal to 0. So I have m squared is equal to negative 1. So m is equal to plus minus square root negative 1, which is equal to I. So in this case, my alpha, so remember for complex conjugate, we have alpha plus beta. I. So in this case, alpha equal to 0, beta equal to 1. So my YH is equal to exponent alpha x, so exponent 0, a cos beta x, so a cos x, plus b sine x. So I obtain YH is equal to a cos x plus b sine x. Alright. Next step, from your YH, determine y1 and y2. So your y1 and y2 comes from your YH. It is the term that you have in your YH. So you see you have cos x and sine x. Okay, so identify y1 and y2 from YH. From your homogeneous solution YH. So let y1 equal to cos x. Okay, so don't take the constant. Okay, just take the term. So y2 equal to sine x. I don't want the coefficient. Alright, so I have cos x and sine x. Okay, so what is my y1 prime? Equal to negative sine x, and y2 prime is equal to cos x. Right, so remember you must get the correct homogeneous solution. Okay, if not you will get wrong y1 and y2, and everything else after this will be wrong. And next step is find Wronskian W. Okay, next step is find Wronskian. Okay, so W is equal to modulus y1 is cos x. I just rewrite back so that it's easy for you to refer later on. Okay, so I have y1, y1, y2, y1 prime, y2 prime. So this is equal to cos x, y2 is sine x, y1 prime is negative sine x, and y2 prime is cos x. Alright, so you cross product it, so you have cos square x minus negative sine square x. So I will get cos square x plus sine square x. So based on the trigonometry identity that you can find in your table of formula, this is equal to 1. Alright, next step is find u and v. Find u and v. Okay, so find u and v. So find u and v, where your u is equal to negative, okay, so let's take a look back, negative y2 fx over aw, so integrate. So we have negative integrate y2 fx over aw dx. So your y2 is sine x, so you have sine x times secant x times secant x over a is 1 and w is also 1 ds. Alright, so secant x is equal to sine x times, so secant x is equal to 1 over cos, so you have sine x over cos x dx. So how to integrate this? Let u equal to cos x, so du dx is equal to negative sine x equal to negative sine x. So du equal to negative sine x dx. Okay, and then I can substitute inside here. So I have du, integrate du over u, which is equal to ln u plus c. Alright, ln u plus c. Okay, so this is equal to, your u is cos x, so I have ln cos x plus c. Okay, next I have to find v. V is equal to integrate y1 fx over a w dx. So this is my u, and v equal to integrate y1 fx over a w dx. Okay, so this is equal to y1 is cos x. So cos x times secant x over 1 times 1 dx. So integrate cos x over cos x dx. So it becomes 1. So you get x plus d. Your v is equal to x plus d. And then next step, yp is equal to uy1 plus vy2. So yp is equal to uy1 plus vy2. So equal to, so what is your u just now? So ln cos x plus c times y1 cos x plus v is x plus d times y2 sin x. Alright, so this is my yp. So finally, yx is equal to yh plus yp. Right, so we have yh is a cos x plus b sin x, right, plus cos x ln cos x plus c cos x plus x sin x plus d sin x. Alright, so I can also combine my a cos x with c cos x and b sin x with d sin x. Okay, where should I write the answer? Okay, so maybe here. So I will have equal to a, b, c, d, maybe e. So I will have e cos x plus f sin x plus cos x ln cos x. Okay, I don't have enough space. Plus x sin x sin x. So plus x sin x. I'm sorry for the very small space. Okay, plus x sin x. Right, so that is my final answer. So this is my yx, right? So that is how to solve a second order differential equation by using method of variation of parameters.